Hey everybody, I wanted to share a quick update with you guys. So if you remember this last time I was showing you this thing I put together in Microsoft Excel that basically calculates all of the geometry as it builds to 2 pi. And of course I had mentioned something about this 10% here, and I'd also mentioned something about the square root of 2, that I was using these versions of square root of 2 for the 11s and for the 7s. If you notice right here, this 1 to 840, these yellow squares here represent the 11s, the green squares represent the 7s. So basically what I've done is I found a way to eliminate all of the irrational numbers simply by using the pi increments. If you remember last time, I keyed in on the pi increments to show you, for example, this is half the size of the side of the Great Pyramid, which is 378. Great Pyramid side length is 756 feet, and so the pi increments are 108. But if we divide it in half, then the pi increments are 54, and I showed you a diagram showing you how it looks when you stack everything together, because the 378, the 0.14 actually represents the 54, but if you put 6 of them together, which represents 2 pi, then your remaining is 108. Well, I've discovered something really interesting I want to share with you guys tonight. I think it has more to do with pyramid code that's being unlocked, but I want to show you this real quick first. So just using the pi increments themselves, I was able to eliminate all of the irrational numbers by doing the following. So what I did was I plug in 54 here. These are our pi increments, and that means that each one of these are 54 times the number. So when we get to 22, pi represents 54 times 22. If we're looking at our 2 pi increments, we have 108 times 22, and that represents pi when we're dealing with 108. When we get all the way down here to 2 pi, 2376 represents 2 pi for 54, and 4752 represents 2 pi for 108 pi increments. So in order to get the square root of 2 values, something really interesting I discovered, and you got to remember that all this is tied to geometry, okay? But all the numbers remain clean. So if you take all of these numbers here and you decrease them by 10%, so if you look up here, I've taken this number up here, 54, and I've multiplied it times 0.9, so I've decreased it by 10%. I did this all along the scale, and so what I discovered was that 378 times the square root of 2 is 534.6, and that falls into the 11 category here. So by taking these pi increments and increasing them by 10%, then I actually get the square root of 2 value for the 7 here. And so for 756, the square root of 2 of that is 1069. So I've got them all down here, and this works no matter what you plug in. But if you notice how clean the numbers are, and down here I've done the same thing, except for the 11s, what I've done was I've increased everything. So here I've decreased it all. Down here I've increased them all. So I've taken the same set of numbers up here and increased them by 10%. And what this allowed me to do was find the square root of 2 for the 11s. So for example, 594, the square root of 2 of that is 840. And if you notice, it falls in the 14 range. So the square root of 2 value and the pi values, or the 7s and the 11s, kind of swap places. When you increase and decrease the set of numbers by 10%, you get the square root of 2. So if you want the square root of 2 for your 7, then you increase all of your numbers by 10%, or excuse me, you decrease them all by 10%. And then you take a look at the value that's the 11, and that is your square root of 2 value. So you can see I've got them highlighted every time. So if I just change this, say for example, to 108, they all change. But for example, 756, the square root of 2 of that is 1069.2. So there are no irrational numbers in here being used at all. but yet we're using pi and we're using the square root of 2. Simply by increasing and decreasing the whole set of numbers by 10%. So anyway, I think that's really interesting, and it keeps the numbers clean. And of course, if you like, you can try this yourself. You can plug all of these numbers in you can just try this yourself in Excel, and then go out there and try to put the geometry grids together, and you'll notice that it fits just perfectly. But the difference is that you retain the relationship between the numbers, because you're not looking at these random number type situations that we get when we use these irrational formulas they give us. Instead, we get very clean numbers that relate to each other in both geometrical form and also degrees, which we've also looked at. Now here's something really interesting that I wanted to show you that it has something to do, I think, with the pyramid code here. So this has to do with the pi increments for the Great Pyramid. So if we take a look at the pi increments, and we're using the 1114 system, so 594 actually squares 756. So in this system, 54 is the pi increment, 108 would be the 2 pi increments. So what I discovered that was really interesting about this is I've told you that this stuff is related to degrees, and if you remember, I was showing you Coffre as an example. If we take the sine of 45 degrees, then we get 0.707, and of course Coffre is 707 feet in diameter. For example, if I take a look at 101 as my pi increments, then you can kind of see what happens here, and this is with Coffre. And then you can also kind of see what values naturally pop up, like pi over 2 and pi and these types of things. But what I found really interesting, which has something to do with pyramid code, is when we get to our formulas, because it turns out that so this was Coffre up here, but it turns out 54 is something very special, because if you take the sine of 54 degrees, you get half of the golden ratio. And right here, I was taken from Wikipedia. It says the equation of 2 sine of 108 degrees over 2 results in the golden ratio. And I think that I feel like I'm kind of a bloodhound on the scent here. I think that this definitely has something to do with this pyramid code, these pi increments that I'm showing you, and so forth. And of course now I can show this to you with using no irrational numbers, and all these numbers remain extremely clean. And of course you can plug this kind of stuff into any kind of geometry like Inkscape and stuff like that, and you'll find that all the geometry fits within itself very well. Something I'm studying right now that it looks like it might be related to this is the figurative geometry some of you might be interested in. So I'm taking a look at all of the triangles that are associated with certain numbers, and I'm finding that certain numbers that we are continually finding over and over, like 21, 36, 66, 378, and then of course if you multiply that times 0.36, because if you remember I was showing you the Fibonacci and phi associated with these types of things. So if we take a look at the figurative geometry here, we can see these same numbers pop up when we take a look at triangles and squares. We have the 1296, we have 5184, and then cubes that you see here. So, and I believe that all of these play a part in the universal geometry as the geometry builds upon itself, either folding out or folding in on itself. And then of course we see some of the same numbers over here that we see in our list. And one more thing I wanted to show you, and I'll let you go, is if we take a look at these irrational numbers here, and we just use something simple like 1, and we let that be the pi increments, then what happens when you decrease these numbers by 10% is it kind of brings these numbers alive. When you get all the way down here, what you find out is that these same numbers, like 594, which squared 756, falls under the 33 mark. But look, here's our 378 and our 756 right here, And then here are numbers related to the Earth, which is the radius, 3,960 and 7,920. So you can see there's a relationship here, and 42 is where this falls in if you decrease them all by 10% and you take a look at it. And these are just the numbers 1, starting at 1 and moving all the way up, or 2, 4, 6, 8, starting and going all the way up, decreasing them by 10% and increasing them by 10%. And these are our square root of 2 values down here. Some of them are very familiar, like this 59.4 and so forth. I just wanted to share that with you guys real quick. So we're not using any irrational numbers anymore in these equations, trying to look at the geometry. And if I can keep from using irrational numbers, I will do it, because I don't think that they are necessary, and I think that everything I see with these guys, they are pushing not to use them. But I find it really interesting, this thing right here, because if you take the sign of 54, it represents our pi increments. It's half of the golden ratio. So if we take, for example, 54, and we take the sign of that, we get 0.809. So we multiply that times 2, which would be 108 divided by 2. We get the golden ratio, and that is actually the value for the golden ratio. It's not any kind of a modification of it or anything. If you take a look at the actual value of the golden ratio, these numbers match. And I think that there is some significance there between these pi increments that I'm showing you here and what we see when we take a look at the Great Pyramid. They're actually showing us another version of the golden ratio hidden inside the pi and the 2 pi increments that we see. So you guys have a great night, and I'll give you more updates as time goes on.